Hello everyone. So this is a small video about how to analyze your UV visible and the fluorescence data for your quinine sulfate experiment. So here I have opened my UV visible data set and here and the fluorescence data set on the background. Okay. First, what we're gonna do is first we'll go to the UV visible data set. And what I'm going to do is I'm going to copy these sample number values to another place, copy these ones, and I'm going to place these ones here. Okay. Place these ones here, place these ones here. And I'm going to copy my wavelength values from here. And I'm going to paste those wavelength values also here. Okay. So now you can see that in each column you have your uh, each column represents one of your samples, and for each cell you have the extinction values at the corresponding or the respective wavelength value. Before doing the actual data processing, what we're going to do is we're going to do a small baseline correction for your data set. Okay. So what I need you all to do is first go to this new position and click equal sign, or enter an equal sign, and click the first cell, and then give it a negative value. Then go all the way down, scroll all the way down, and click this last wavelength value. Okay. So what we're going to do is we're going to subtract the absorbance value uh, value at the last wavelength from each and every data point for each sample. Okay. So here I have my first sample's last data point. So I'm going to include a dollar sign just in front of the number. Okay. In front of the number. So I do that and click enter. Okay. Click enter. Then you will have your the baseline corrected value at 280 nanometers. So remember, in this equation, you click this first cell here, then that one subtract by the last cell, but make sure in front of the number, just the number, not the column value, not the letter, just in front of the number, include the dollar sign, and press enter. So you will get this value. Then you can drag it like this. So how to do, you can move your cursor here, and you can see that your cursor suddenly changes into a black cross. So you can click it, drag it all the way up to this last sample number. Okay. Then once you drag it here, you can double click again when this black cross appears. Okay. Double click it, and it will automatically update for all the cell data points. And you have to do this only for the UV visible data set. Okay. Not the fluorescence data set, only for the UV visible data set. Now you have your baseline corrected UV visible data set. Okay. Now we can start analyzing the data. So first, what you need to do is first you have to select all the data points of the UV visible spectral data, and plot a graph which shows your wavelength versus absorbance values. Okay. So you will have a plot something like this. Okay. You're going to delete this legend, and you can name this graph as absorbance versus wavelength. Wavelength in nanometers. And then I'm gonna select go to this chart elements, and I'm gonna include axis titles here. Then this should be the absorbance. This is the wavelength. in nanometers. And also you can click on the double click on these like horizontal axis values, and then go to this axis options here, then go to axis options here, then you include your starting wavelength as 250 nanometers, 250 nanometers, and your end wavelength as 600 nanometers, because that is a wavelength range that we use to acquire the data. Sorry, 280, this should be 280 nanometers, 280 nanometers to 600 nanometers. So you have your baseline corrected absorbance versus wavelength plot here. Okay. So then what you're going to do is you're going to copy your concentration values here from here, and you're going to paste it somewhere around here that you can work. You paste the concentration values here, and we need to plot the absorbance in a baseline corrected absorbance values at 350 nanometers, 350 nanometers versus the concentration plot. Okay. So what I'm going to do is I'm going to go down and find these 350 nanometer values, and I'm going to copy the absorbance values at 350 nanometers, and I'm going to paste it in here in transpose mode. Okay. So in order to do that, I'm going to right click on the cell above and go to paste special values transpose. Once you do that, you will have your concentration values in this column and your absorbance values at 350 nanometers in this column. Okay. So once you do that, you're going to select all of these and then go to this plot, scatter plot option. Okay. Now you have a plot. I'm going to name this one, label this one as absorbance within parentheses 350 nanometers versus concentration. And our concentration values are in millimolar values. Millimolar. So you have this one. Okay. Once you do that, just go to this axis titles. Then go to this one and label this one as absorbance. And the x-axis as concentration. And which is in millimolar values. Okay. So now you have two nice plots. One is absorbance versus wavelength values for all of the samples, and one is absorbance at 350 nanometers for all the samples versus their respective concentration. Okay. So this is for the initial UV data set. Now we have to do a similar one for the fluorescence data set as well. Okay. So we can go to the fluorescence data set, and here I have the fluorescence data set. So I'm going to select all the spectral data, and then I'm going to plot it. Go to insert and plot it plot the scatter plot option. Okay. Then I'm going to remove this legend. And I'm going to adjust the axis from 380 to 590. And I'm going to label this one as fluorescence intensity. Versus wavelength. In nanometers. And then I can like go to this chart elements and include axis titles. So this one is the fluorescence intensity. So you can put it as intensity here. Intensity here. And here you can put wavelength. Wavelength in nanometers. Nanometers. Once you do that, you have your first figure for your fluorescence data. And the second one is we need to plot the fluorescence intensity at 450 nanometers versus concentration. So I'm going to select the fluorescence intensity values at 450 nanometers. I'm going to copy these ones and paste here in the transpose mode. So as previous ones. So I'm going to right click on the cell, go to paste special, values, transpose, like that. So you have your fluorescence intensity at 450 nanometers, 450 nanometers in here. So I'm going to copy the concentration values, and I'm going to paste it right in front of that one. Okay. So then I'm going to plot these two together and insert another plot. So you can see that like our fluorescence intensity versus fluorescence intensity at 450 nanometers versus concentration plot, which is appearing like this. Okay. So here I'm going to use fluorescence intensity within parentheses 450 nanometers because we use 450 nanometers versus concentration. In millimolar. Okay. And I can label the axes as well, axis titles. This is intensity, and this is concentration. In nanometers. Okay. Okay. Now you should have four figures. One is the fluorescence intensity versus wavelength, and the fluorescence intensity at 450 nanometers versus concentration, and also the UV visible data set, UV visible spectral data set, baseline corrected UV visible absorbance spectra data, spectra plot, and the absorbance at 350 nanometer spectra. Okay, with respect to concentration. Okay, so next, what we're gonna do is you can see that in the fluorescence data set, the fluorescence data, as the concentration increases, the fluorescence intensity start to deviate from the linearity and start curving down. Okay, due to the inner filter effect. So what I'm gonna do is I'm gonna correct the inner filter effect of this fluorescence of this fluorescence measurements. So here we have our as acquired fluorescence intensity. I'm gonna label it as IF at 450 nanometers, 50 nanometers. This is a measured one. And this column, we have the concentrations. So in order to correct for the inner filter effect, we have to use the equation that is given in your lab manual. Okay. So in order to correct for the inner filter, in order to correct the inner filter effect, I'm going to use the equation that is in your lab manual, and it has a couple of like requirements in order to do that. So first, you have to get your as acquired fluorescence intensity. That is the one thing, and also you have to have the absorbance values at the excitation wavelength and the emission wavelength. Okay. In this case, remember, we excited all the samples at 300 nanometers. So for the absorption at the excitation wavelength value, we have to get the absorbance value at 300 nanometers. So we can go to UV-Vis dataset, and go to 300 nanometers, and I'm going to copy this absorbance values. Okay, copy these absorbance values, and I'm going to go to the fluorescence data set, and I'm going to paste it just in front of my uh, uh, as acquired or the experimentally measured fluorescence intensity. So values, transpose, and you will have your absorbance values at excitation wavelength. I'm going to write AEX. Okay. So now we need absorbance values at emission wavelength as well. Okay. So in this case, your emission wavelength is 450 nanometers. Here you have your fluorescence data set. Now you need your absorbance values at 450 nanometers. So what we're going to do is we're going to go back to the UV visible data set, and then I'm going to copy the absorbance values at 450 nanometers. Copy. And then I'm going to paste it back again, in the, go back again and paste it in the fluorescence data set. So values, transpose, and this is the absorbance values at emission wavelength. Okay. A emission. So you can see in this case, it is like almost negligible. Okay. A emission. Okay. Now here, now you have your as acquired fluorescence intensity values, absorbance values at excitation wavelength, which is 300 nanometers, and the absorbance values at the emission wavelength, which is 450 nanometers in our case. Okay. Now I'm going to plot here. I'm going to include an equation where like I'm going to select my as acquired fluorescence intensity, and I'm going to multiply it by 10 to the power. I'm going to include a couple of parentheses here. So you will see that we are trying to enter the equation that is given in your lab manual. So this U4 is your U4 cell represents your fluorescence as acquired fluorescence intensity, and multiplied by the absorbance at the excitation wavelength. So excitation wavelength into excitation path length. Okay. So in this case, excitation path length is 0.4448, which is given in your lab manual. And here you have to include your absorbance at the emission wavelength, which is multiplied by the emission path length. In your case, the emission path length is 0.5457. Okay. Now you have your equation here, which will give you the inner filter effect corrected fluorescence intensity at 450 nanometers. So we're going to enter here, and then I'm going to drag this down, and this is IF corrected. And then I'm going to copy this as acquire. I'm going to include a new column here, couple of columns here to have some gap. I'm going to copy this as acquired inner filter, as acquired fluorescence intensity values to here, and we have our as acquired and the inner filter effect corrected fluorescence values here, and I'm going to copy these concentration terms, and I'm going to paste it right here. Okay. So we have our concentration, We have our experimentally measured or the as acquired fluorescence intensity at 450 nanometers, and the inner field effect corrected fluorescence intensity, which we got from our equation or the included equation, which is given in your lab manual. Okay. Now we can plot these three together and see what we're going to obtain. And you can see that the blue color these blue colored one dots represents your experimentally measured fluorescence intensity, and this orange colored one represents the inner field effect corrected fluorescence intensity. Okay, so now once you have this one, you can like label the axes. This one is intensity. The y-axis is concentration. Which is in millimole. So now your orange colored one is the inner field effect corrected one. So inner field effect corrected one, and the blue colored ones are the as acquired or the experimentally measured fluorescence intensity at 400 nanometers. So like I'm gonna write here as, or we can remove this one. Actually, you already know what is inside. So you can use this orange colored data points to generate and include a trend line here using these orange colored ones. I think like due to like the experimental errors and maybe the inaccuracies or the concentration losses in the UV-Vis measurements, this is not that much linear. Otherwise it should be like perfectly linear with your sample. So like you can see that like if you remove like one data point from here, you can clearly see the linearity of your measurements. Okay, so like if you lower it again, like one more, you can clearly see that like your orange color data points are much more linear data set. And also you can see that you can see that even at like very low concentration, your fluorescence intensity starts deviating from the linearity due to the inner field effect. So now, since I have like the inner field effect corrected ones and the as acquired data points, I can use the inner field effect corrected data set to find the unknown concentration value. So in this case, we can remove this last data point because it looks like an outlier. Then you can get like a nice trend line for the inner field effect data set. So you can use this trend line and you can click on this trend line and go to the trend line options, and you can get the equation for your fluorescence intensity at 450 nanometers, which is inner field effect corrected. Okay, inner field effect corrected one. So use this equation to find out the concentration of the unknown sample. Okay, so you can plot the fluorescence intensity uh, include at 450 nanometers for your unknown sample, and you can include this equation to get the concentration of your unknown sample. Okay, this is the fluorescence measurement. You can do a similar thing. You can use the UV visible data set, and you have your unknown samples values here, and you have your calibration plot that you got for 350 nanometers. So you can get the trend line for this one, and then you can go to this trend line options, more options, then go distillate equation on the chart. You can use this equation here and the UV visible extinction value at 350 nanometers for your unknown sample, and find the concentration of your unknown sample. Okay, so you can compare the concentration values that you are getting for your unknown sample using UV visible dataset and the fluorescence dataset, and see what you can propose any like error, any like you can include anything on your discussion. Why may, if there is any like deviations, what is the reason that deviations may have occurred? So like you can include anything that you think that cause like differences in the uh, unknown concentration measured using UV visible method and the fluorescence method. So I hope this video helped you. Like let us know if you have like any more questions. So I hope you all uh, have learned something in today's experiment. So like please reach out if you have any more questions regarding this one, and we are happy to answer. So have a great week and have a good night. Thank you.